Here in examples here. The total number of the patient 60 paracetamol is given. Achieved 50% of the pain relief is the 40, placebo 90 and 30. The odds of achieving the significant pain relief with the paracetamol, so odds of disease in exposed means the 40 divided by odds of disease in the non-exposed means the 20. The 40 by 20 with placebo, so 30 by 60 equal to 0.5. So therefore the odds ratio will be the 2 divided by 0.5 equal to 4. So the odds ratio and relative risk, these are the two different ways that we need to calculate. So odds ratio, just to remember, exposed divided by non-exposed, my dear. A box for the odds ratio. So OR equal to odds ratio exposed divided by non-exposed. So it's the exposed divided by non-exposed. So 40 divided by 20, 30 divided by 60, and ratio just exposed divided by placebo. So odds versus probability. In contrast, the probability is a fraction of times you would expect to see an event in many trials. When expressed in a single number, probability is always between 0 and 1. Probability 0 and 1. So if you take the examples of rolling a dice, the probability of rolling is a 6 is 1 by 6 is 0.166. The odds of rolling a 6 is a 1 by 5 or 0.6, 0.2. Odds ratio are the usual reported measure in the case control study. So odds ratio is a case control studies. It approximates to the relative risk if the outcome is interest is there. For example, if you look at the trial comparing the use of the paracetamol for dysmenorrhea compared to the placebo, we may get the following results. So all of the achieving significant pain and also achieving therefore the odds ratio. So what I'm saying, my dear, one of the important box that we need to remember, odd ratio equal to is needed for the case control study. Case control. So OR, all case control, odds ratio is the case control studies. And here is the odds ratio, the calculation, so just go through them. So this is one important point, but the odds ratio very close approximate to the relative risk if the outcome of interest is rare. And the question so that you can odd ratio, calculate the odd ratio as well. Here is also the odd ratios. Here is also odd ratio rather than the risk. There is another calculations for the relative risk and hazard ratio. Similar to the relative risk but used when the risk is not constant to the time, as you already talked about the hazard ratios. Survival time. And what does the power of the study equate to? Power equal to 1 minus probability of type 2 error. So this is another box. Incidence and prevalence. I would like to give one box, my dear. The PID means the prevalence equal to incidence into the D for durations. So this is very important, mind. The prevalence incidence is the duration of the condition. Chronic disease prevalence is greater and acute prevalence incidence is similar. There's a box that we need to remember. And incidence is the number of new cases, and the two, this is not needed for you people. So prevalence measures the current burden of the disease population for the facility planning and resource allocation. Prevalence versus incidence. Some of the words, some of the differences, 1 star. And which one of the following statements regarding the epidemiological measures is correct? Cross-sectional surveys can be used to estimate the prevalence. So cross-sectional studies for the prevalence of a condition of the populations. So the cross-sectional for the prevalence. Pre-test and post-test probability and odds. Pre-test probability is a triple star topic, my dear. The proportion of the people with the target disorder in the population at the risk of a specified time. So specific time. The point prevalence. P-test is a point prevalence and time interval is a period prevalence. So prevalence of the rheumatoid artery in the UK is 1%. So pre-test probability is nothing but the prevalence. Post-test probability, the proportion of the patients that the particular test results who have the target disorder. So post-test, test is a target disorder. So post-test probability equal to post-test odds divided by 1 plus post-test odds. Another is the pre-test odds. Pre-test odds equal to pre-test probability 1 minus pre-test probability. Post-test odds, once again, pre-test, post-test odds. The odds that the patient has a target disorder, that is the test is carried out, the post-test odds equal to pre-test odds equal to likelihood ratio. Or the likelihood ratio is the positive test result equal to sensitivity divided by 1 minus specificity. So these are the 1, 2, 3, 4, 5. The pre-test is the prevalence, post-test probability equal to post-test odds divided by 1 plus post-test odds. Pre-test odds and post-test odds. Pre-test odds equal to probability 1 minus pre-test probability. Post-test odds equal to pre-test odds into likelihood ratio. You need to get them by heart sometimes. Which of the following the pre-test? I said the pre-test for the very focused triple star prevalence, the single toe. Pre-test prevalence, that's it. Significance test, my dear. The significance test is really important. I'll give you the very simple word so that you can remember, my dear. So null hypothesis states that the two treatments are equally effective. It hence negatively phrased. Null hypothesis states that two treatments are equally effective. A significance test uses the sample data to assess how likely the null hypothesis is to be correct. For example, there is no difference in the prevalence of colorectal cancer in patients taking the low dose aspirin compared to those who are not. Alternative hypothesis H1, this is H0. The null hypothesis H1 is an alternative hypothesis, the opposite of the null hypothesis. There is a difference in between the two treatments. So two hypotheses are here, null hypothesis and alternative hypothesis. I put a box, my dear. Null means no differences, zero differences, and alternative hypothesis differences. So null no, alternative differences. A p-value is the probability of obtaining result by chance at least as extreme as the one that was actually observed, assuming that the null hypothesis is true. And is therefore equal to the chance of making a type 1 error. So there are two types of errors, my dear, the type 1 and type 2. Before coming to this type 1 and type 2 errors, when testing the null hypothesis, you see there are lots of things here, but I like to give a good examples here. Null hypothesis, the type 1 error, the type 2 error. The type 1 is the doctor saying a male person, you are pregnant by doing a test. In contrast, the type 2 error is she is pregnant, but the doctor is saying you are not pregnant. So type 1 error is a false positive test. In contrast, the type 2 is a false negative test. Type 1 false positive, false negative. Just remember now, in a male person you are saying you are pregnant. It's a false negative test, it's a type 1 error. In contrast, in a pregnant lady you are saying the test is negative. So this type 2 error means the false negative test. So type 1 is a false positive, type 2 is a false negative. Type 1 is a you are pregnant, false positive. And type 2, you are not pregnant, false negative. So you see, same, you are pregnant, you are not pregnant. Yes, you see, you are pregnant, you are not pregnant. And what are these errors? The same topic, the type 1 and type 2. So type 1 error is the false positive conclusion, and type 2 false negative conclusion. Type 1 error, the stating differences when there is no difference, that is called the alpha, and once the type 2 error called the beta. The stating no difference when there is a difference related to the p-value and occurs the sample size is too small in the type 2 error. The probability is distributed tails not needed here. So only the type 1 is the false positive, type 2 is the false negative. Type 1 is the alpha, type 2 is and beta. So every the same, you see the type 1 error, false positive, type 2 is a false negative. You are pregnant, you are not pregnant. Null hypothesis, patient is not pregnant. Incorrectly reject the null hypothesis. Null hypothesis, the patient is not pregnant. Incorrectly accept the null hypothesis. Here is also same talk. The type 1 error, good guy, shoot. The type 2 error, the bad guy, don't shoot. Even the bad guy. What is the difference the type 1 and type 2? Type 1 error is a statistical calls for the rejection of a null hypothesis which is factually true. Type 2 error, the type 2 error, the statistical does not give enough evidence to reject null hypothesis, even a null hypothesis should factually be rejected. We may reject H0 when H0 is true, known as the type 1 error. We may accept the H0 when in fact H0 is not true, known as the type 2 error. A type 1 is a false positive, type 2 false negative, alpha and beta. The single talk the type 1 false positive, false negative, and once again the alpha, and once again the beta, and type 1 and type 2. And type 1 is the null hypothesis, type 1 error, and type 2 is the alternative hypothesis and type 2 error. There are some other photographs so that you can understand. We can get back to our knowledge here. So this is a very important. Type 1, the null hypothesis is rejected when it is true. Type 2 null hypothesis is accepted when it is false. Make a box, my dear. This is really important. The way I've written. So true, rejected. Now is rejected when it is true, accepted when it is false. Null hypothesis is rejected when it is true and accepted when it is false. So rejected true and accepted else or false. So yes, means the type 1 error is a false positive, type 2 is a false negative, alpha, and this is beta. And once again the type 1 is not affected by the sample size, but the type 2 is determined by the sample size and alpha. So these are the important talk, and make a box, my dear. So once again, type 1, type 2, type 1 rejected true, type 2 accepted false, false positive, false negative, and determined against a precise significant level. This is alpha, this is beta, and this is not affected by sample size, but this is affected by sample size and alpha. So make a box once again. So type 1. So type 1 equal to, once again, the null hypothesis, as I said, the rejected true. Once again, this is false positive, and this is called alpha, and not determined by the sample size. Not sample size. In contrast, the type 2 equal to accepted. When it is false, this is false negative, and this is beta and dependent on sample size. So once again, type 1 rejected, true, false positive, alpha, not sample size, accepted, false. Once again, the type 2 false negative, beta on yes. So I'm just cutting down from here so that you can remember all of them together, and that will be helpful. Once again, the separate box. So here's the type 1 is the false positive, type 2 false negative, type 1 alpha, beta, not sample size on sample size. Once again, the type 1 rejected, true. In contrast, the type 2 accepted, false. So yes, my dear doctor, the summary box that we already got it, and based on that, some of the questions will come up, so we can get them very well. So the same token, the treatment best describe the type 1 is the null of the rejected, when it is true, means the rule. As I say, the type 1. Definition of the p-value. P-value is a probability. Yes, P for probability of the obtained result list as extreme, assuming the null hypothesis is true. Probability is true. And some of the study design evidence and recommendations. So this is 1-star or double-star topic. Might just go through them. And what level of evidence does a randomized control trial offer? So it's a 1B. So this is written as 1B randomized control trial. So this is the box minor. So 1A evidence from the meta-analysis of 1A, at least one randomized control trial. 1B. So 1B is a one randomized control trial, and 1A is a analysis, means a meta-analysis. 1A. And 1B is an at least one randomized control trial. And 2A, once again, 2A, 2B, and 3 and 4. So 2A, at least one well-designed control trial which is not randomized. So 2A, level of the evidences. 2 evidence means at least one well-designed control trial. One well-designed control trial. 2B, once again, evidence from at least the one well-designed experimental trial. This is well-designed, so experimental trial. And 3, evidence from case correlation and comparative studies. And 4, from panel of experts. So yes, my dear doctor, you need to make a box for study design and the evidences. Means, what does the evidence and recommendations mean? Evidence, of course. Evidence means evidence-based, so that you can rely on the evidences. If it is written that this is 1A evidence, means it's a less evidence-based rather than 4. Yes, is the highest grade of evidence. So level of evidence is sometimes is really important. So how this is level of evidence is done. So you need to learn for 1A. If you write 1A equal to meta-analysis. I'm writing the meta-analysis. So 1B, once again, equal to at least one randomized control trial. So yes, randomized control trial. Meta-analysis, so randomized control RCTs. So 2A equal to, once again, at least one well-designed control trials. So we can write like that, well-designed control trials. So WCT. Meta-analysis, we can write the MA. Yes, meta-analysis. Randomized control trial and the well-designed control trials. And 2B is a well-designed experimental control trials. So well-designed control trials, and once again the 2B equal to well-designed experimental control trials. So yes, well-designed control trials and well-designed experimental trials. So well-designed experimental trials. And 3, once again, equal to case. So CCC, the case control and also the comparative studies. And 4, once again, is a panel of experts. So experts equal to experts. So these are the box minded, the meta-analysis, randomized control trials, WCT, WET, and then the CCC and E. So that will be helpful to know. Grade A, based on evidence from at least the one randomized control trial, means the A, B, C. So 2B and 3 all together, and C for 4. So once again, make a box. So evidence recommendation, grade of recommendations, A evidence equal to, once again, the 1. B is nothing but the 2 plus 3, and C, of course, equal to 4. So this is the grade of recommendation. So we have the study levels of evidence as well as the grading of recommendations. So here is some of the phases of study. The clinical trials are called 4 phases is given here. The study design, the new drugs, the 1-star topic, my dear. And there is a question, superiority trial. Which of the following study design would require the most patients to produce a significant result? To prosecute the superiority trial. Significant result. As a superiority trial compares a new drug with an existing treatment, which would also lower the HbA1c, a larger sample size required to demonstrate significant difference. So significant result is a superiority trial. Types of study is a RCT, cohort study, case control, and the cross-sectional survey. So Framingham Heart study is one example, my dear, that you need to know, the cohort study. So C for cohort study, C for cardiac study, just to remember, my dear. C for cohort, C for cardiac study, heart study. Another questions, right? With the most performed study design, a part of research project you are trying to ascertain whether the use of Dewmans in infants is linked to the sudden infant death syndrome. What is the most appropriate study design? The case control study. Sudden infant death is relatively rare. Case control design is more appropriate than a cohort study. Sudden infant death syndrome is rare, so the case control relatively rare. So the single word, the rare. So that's the case control study will be more appropriate. What is the usual outcome measure of the cohort study? So cohort study is a relative risk. Cohort study is a relative risk. Look at the ratio there is smoking and the breast cancer. Cohort study is a relative risk. Cohort is a relative risk in the box. And once again, the case control study, that's how I talk the odds ratio. Case control study is an odds ratio. Intention to treat analysis. Here, how would be data analyzed? Include the patient who drop out in the final data set. A randomized control trial compares the two drugs used in the initial management of rheumatoid arthritis. After being assigned to the randomized groups, a number of the patients drop out due to adverse effects of the medication. So, include the patients who drop out in the final data set. The data analyze. How should the data analyzed? So intention treat analysis is a method of analyzing randomized controlled trials in which all the patients randomly assigned to one of the treatment analyzed together, regardless of whether not they complete the received their treatment. So drop out all them together. Intention treat analysis is done to avoid the effects of the crossover or dropout. Avoid the crossover and dropout box, which may affect the randomization to the treatment groups. So summary intention to treat the single word, avoid the dropout, and include the dropout groups as well. And some of the laws and ethics less than 1 star topic might all them together. So my dear, let me give you the summarize here, the statistics that we learned, my dear. So what you need to do, just make the SS boxes that you already got from here and try to focus onto the question embedded here. That will be enough and more than enough to prepare yourself for the statistics, my dear. You will do the best, my dear. I hope that you enjoyed. Thank you very much. Thank you once again.